So here's an example of a breadth first search function, and let's see if we can make this a little cleaner the way we did with the previous example, which was a merge sort. So what we do is we write a function called BFS, which accepts two arguments. One is the adjacency list of the graph and the root vertex from which you want to start traversing the graph. So we keep a dictionary called visited, which simply records whether a particular vertex has been visited or not. We initially fill it with all false values, then we initialize a queue, and then we add the root to the visited list, or rather we mark the root as visited, we add it to the queue. And while the queue has something, we keep on looking at the neighbors of whatever was the first element in the queue and keep on doing the same thing over and over again until the queue becomes empty. So let's see what we could do here. So as usual, I'm just going to copy this function and we're going to go line by line and see how we can make it better. So you see, the first problem that I see with this particular approach is that visited is a dictionary. Now, when you do a breadth first search, the order of traversal matters a lot, and a dictionary may not necessarily give us the order of traversal. Of course, this particular issue has been fixed in some of the later lectures, but nevertheless, what we're going to do is simply turn this into a list. And therefore, we won't need this particular for loop, which marks every vertex as unvisited. But then we also know that we are going to use the traversal by starting at the root specified in the function. So what we're going to do is, instead of initializing visited to be an empty list, we are going to add exactly one particular element in it, which is the root. Now, queue is also a class that we implemented specifically for this particular exercise. But in Python, thankfully, there is an interesting data structure called a deck. So what a deck is that it's exactly like a list, except that it supports push and pop operations at either end. So it can be used efficiently as a stack as well as a queue. So let's do that. Let's use a deck instead of a custom class called queue. So from collections import deck. So it's spelled DQ, but it's pronounced deck. So what I'm going to do is simply create a deck. And of course, even there we need to add root initially, because that's what these two lines do. So we can essentially get rid of that. And here's another place where we can make it a little more readable. We want to keep on doing something while there is still something in the queue. And since our queue is now a deck, and a deck is like a list, we can simply replace this whole thing as length of queue. So while length of queue is not 0, you can always keep on doing something. And then what we do is we simply pop the first element in the queue, first in, first out. So let's call this something like vertex. This is the next vertex to be visited. And so we say queue dot pop left. So you see that typically dictionaries have simply a function called pop, which would pop the last element. A deck has a method called pop left, which pops the first element, right? And the problem with pop 0 is that it's expensive in a standard Python list. In a deck, it becomes a lot more efficient, right? So then we say that for neighbors in A of vertex, remember that this is an adjacency list. In fact, it's neighbor because you're only processing a single neighbor at a time. And since visited is now a list, we say that if neighbor not in visited, we first of all append neighbor to the visited list, and then we also append it to the queue. And that's it. That's breadth first search for us. Of course, there seem to be some syntax error. Oh, of course, we forgot to add a colon, so we've done that, and there we are. That is our breadth first search algorithm. A lot smaller, a lot more readable.